So, basically, very similar to the circle, very similar to the parabolas and everything else we've been doing. In this case, we again have two separate, unique forms. This form is changed based on the major and minor axes. Okay, the major axis is the axis in which a more distance from one, or the unit, the length, is longer from one side to the other. So in this case, what's my major axis? Which one?
Horizontal.
It's the horizontal axis, okay, or the x-axis. Because look, there's more distance from here to here than there is from here to here. Does everybody agree with that? Okay, and so that is your major axis because it has more distance. And we don't say that major axis is the x-axis. We say the major axis is horizontal. It's more or less the direction of the major axis. Over here, our major axis is what? Vertical. Okay? And that's because there's more distance vertically between the two endpoints than there is horizontally. So let's talk about our ellipses. This A distance is the distance from one side to the center. Your A distance is always going to be the distance on the major axis. Okay? No matter what. Notice how right now my A distance is horizontal from here to here. Over here though, my A distance is vertical from here to here. That's because A always goes with the major axis. In order to find the distance of your axis, your major axis, you would do 2, or the length of your major axis, you would do 2 times A. Because this is A and this is A, so 2 times A is logical. B, on the other hand, is the distance from the point on your ellipse, the outside point on your ellipse, to the center off of your minor axis. Okay? And again, B is vertical here, but horizontal there. What you can't see on the screen yet is the length of the minor axis. What do you think how do you find the length of the minor axis? 2b. 2b. It's the entire length is 2b. Because half of it is 1b, and then add another one, it's 2. Really? Alright, now, of course you have your center, and then you have your foci out here. Now, the distance from your center to your foci is your C value. Okay? Depending on the ellipse and the graph, you could just count that out, but there is a way to find C. The way you find C is using the formula C squared equals A squared minus B squared, right there in the middle of the two. You guys see that? It's kind of a jacked up Pythagorean theorem.
That's to find the foci?
Yes. So it's right here. I'm sorry, that's to find C, yes. But you need C to find the foci. Center is still at HK. That hasn't changed. What do you notice about your equations? What's going to happen to your H and K? They're going to switch. We call it the... When you pull out H and K, they're going to be what? I'm talking about H and K. When you pull them out of the equation, they're going to be what? Opposite. Opposite, right? So if you have like x minus 3 here, when you pull it out, it's going to be a positive 3. We've already talked about the major axis, the minor axis, and then the lengths, how to find the lengths. The foci on this one, okay, now let's talk about the difference between, what's the difference between these two, formula-wise, or equation-wise? K and H are switched. Yeah, and when you switch the y minus k squared and the x minus k squared, do you take the b with it?
No.
No. So if you notice here, x minus h squared is over the a squared. Over here, y minus k squared is over the a squared. That is because a squared is always the biggest. And that's how you determine if you're dealing with a major axis horizontal or a major axis vertical. Okay? It's a squared is always the biggest. So if your biggest number, if this is 36 and this is 9, that means your major axis is on the x-axis, or the horizontal. But if you have 36 here and 9 here, that means your major axis is vertical. That's the main difference between the two. Any questions on that? Okay. Let's go ahead and jump into some examples. All right.
Can you go to the very bottom line of that graph?
Of the graph?
The chart or whatever.
Oh, that just says minor axis 2b. And it says in both columns because it's the same. Length of minor axis is 2b. Okay, so here you go. We're gonna find the important information here. Based on this equation, x squared over 36 plus y squared over 9 equals 1. Now, here's the deal. The major information we start with. Oops. Okay, we start with the center of the circle. What's the center? Or the ellipse? I said circle, sorry. Center is 0, 0. Somebody tell me why.
Because X and Y are on themselves.
Yeah, because x and y are by themselves, or there's no h and k. The only way there can be no h and k is if it is 0. How does my pen end up on this desk for you? It's killing me. Thieves. Okay? Huh? Who did it? Probably your fault, isn't it? It's the blight kid that did it.
It's not stole, it's
You said the blight?
Yeah.
I like that.
Or the white kid.
So does he like steal it
his
and
white
bring it
kid.
back and apologize for it?
That's right. Which is which though?
Yeah.
Ah. All right. So next thing I want to find is the major axis. What is my major axis here?
Hey, that was really, really racist. What you just said.
What's the major axis?
Oh, it's
6.
horizontal.
Horizontal.
How?
Because the X is bigger.
You understand that for real? Okay. Remember, we just talked about this. Remember, major axis is the one with the bigger number on the bottom. So the major axis goes with the a squared. The a squared is always the bigger number. So a squared must be 36 because it's bigger than 9. Since it's under the x, it's the x-axis. If it's the x-axis, that means it's horizontal. Right? Okay? All right, now, we don't just need to find out which it is. We need to also talk about how long it is. Okay, how long is what's the length of the major axis?
6.
Okay, it's not 36. How do I find the length of the major axis? What's the formula?
2A.
2a, right? Okay, I know the a is what?
6.
A is 6. How do I know a is 6?
36.
Because it's
Square root.
Square root of 36.
Yeah, because I know the a squared based on the formula is 36. Square root of 36 is 6. So a must be 6. So then, if I want to find the length of my major axis, I have 2a, which is 2 times 6, or 12.
Why was it so hard when I did it myself? So easy.
All right, let's take a look at the minor axis. The minor obviously is vertical. What's the length of the minor axis? Okay, it's 2b, right? What is b? 3. Same reason, because 9 is the square b squared. So to find out what b is, not just squared, you square root 9 and you get 3. So then you have 2 times 3, and you get 6. So the length of the minor axis is 6. Bless you. And then the last thing we want to find is a foci. How do we find this for this? How do you find that for this problem?
36 minus 9.
Okay, not yet, but we're going to do that. We're going to need that in a second. Say it again.
Is it 36 minus 9?
Hang on, I just want to know the formula.
Oh, it's
Or the
6
setup.
equals a squared minus
Nope, hang on. You guys are both one step ahead.
H plus or minus C. Okay.
Yeah, I just wanted to make sure you understood. It's h plus or minus c comma k. We need that one because we're dealing with the major axis that's horizontal. Now, in order to find the foci, we need to know what c is. So now, you guys that were saying the c thing, now we need to plug in c squared equals a squared minus b squared. The good thing about this is, we already know a squared is what? 36 minus b squared is 9. C squared is 27 for those people who can subtract. Okay? And if I want to find it, c, I have to square root it. So c squared is 3 square roots of 3. Now sometimes you will, I talked about this in my last class, 3 square roots of 3 is an exact answer because you have not rounded anything yet. It's like a fraction. A fraction is an exact answer. Once you start doing a decimal like 3.14, then you're rounding. Now it's approximate. It's not exact. So right now I want the exact answer because it's not asking me to graph. When I have to graph this, then I'm going to have to break it out and get a decimal so I kind of have an idea where to plot. Okay? So then my foci then is going to be h, which is 0, plus or minus 3 square roots of 3, comma 0. How many points am I going to have here? 2, right? There's 2 foci, 2 points. That's what the plus or minus is for. So what are my 2 points? So negative 3 square roots of 3, comma 0, and positive 3 square roots of 3, comma 0. And that's it. So we found the center.
Oh my God.
We found the length and the direction of the major axis and the minor axis. And then we found the foci. So that is the important information. When I ask you to find the important information, that's what you want right there. Any questions on that? Okay. Let's look at our next example. It says write an equation for the ellipse. Well, the first thing I need to do is determine which form I'm going to use. How do I determine which form I'm going to use? Yeah, I got to find out major axis and which one's the minor axis. Which is the major axis? Vertical. Now, somebody in my 5th period class piped up and said, well, vertical because it looks longer. Okay? Now remember, and I know juniors, you're done taking your tax test and all that stuff, but in college and sophomores taking the EOC, you got to be careful. Just because this is a Cartesian plane, they could throw a loop at you. They could say, okay, these are 1, 2, 3, 4, 5, and these are 5, 10, 15, 20. And if they do that, you can't just take a look by just the way it looks. You have to actually count it out. But in this case, the vertical axis is our major axis. So vertical is major. So what equation are we going to use?
Y minus K.
Over a squared.
So y minus k squared over a squared plus. Now that plus is important. Because the plus, there's another form just like this, but it has minus. That's the difference between an ellipse and a hyperbole. Okay? So, here's the deal. Y minus k squared plus, or over a squared plus x minus h squared over b squared equals 1. So this is actually pretty simple. What is my center? 0, 0. Because if I go down here, I go 1, 2, 3, 4, 5. And then here I go 1, 2, 3, 4, 5. So 0, 0 is in the middle there. And then over here, 1, 2, 3. And then 1, 2, 3. So it is in the middle. So our center is 0, 0. So we can start to fill in our equation that way. So now I have y squared over a squared, right? Plus x squared over b squared equals 1. Okay? Let's get rid of this. What's a?
Five squared?
5. Okay? 5 squared. Well, 5 is a. Okay? Because we're looking at the distance from the top of the ellipse to the center on the major axis, right? So here's my major axis at the top. 1, 2, 3, 4, 5. So that distance is 5. So now I have y squared over 5 squared plus x squared over, what's my b? 3. 1, 2, 3, right? So over 3 squared equals 1. Now I have y squared over 25 plus x squared over 9 equals 1.
That's it?
That's it.
Will we ever like go further on that? Or is it?
Further than what?
Now we have homework?
No, we have more examples. Okay?
Now, will they want us to do an equation, then also find like both sides and all that?
Yeah, okay, yes, that's what you're talking about. Yeah, there will be times where, and there's an example that we were gonna do, but we're gonna run out of time, so we're not gonna do that. Where you actually write the equation and then you find all the important information. Okay. But the good thing is, when you're doing it from a graph, especially, it's easy. But like in a second, the example we're about to do, you're not getting a graph, but you still have to write the equation, and then you would have to find the important stuff. So you would still have to use it, but that's just like we did in the first time, the first example. All right, so let's look at our next one.
What happens if it's off center?
Nothing, you just use a different center. You'll have a different point at center.
What about when you count your A?
You'll still be able to find the center, it's the midpoint. Right, here's the deal. She's asking, what if it's not 0, 0? Well, if you find the length of A, the entire length of A, because you could do that by counting, right? From one end to the other. Then you could do the midpoint to find the center, right? And we're going to do that here in a minute. Okay, so here we have x squared plus 4y squared minus 6x minus 16y minus 11 equals 0. We need to put this in one of the forms. Okay? What do we need to do here? Anybody?
Complete the square size.
We're going to have to complete the square. Okay, this is coming back. So I'm going to go ahead and set this up. So we're going to have x squared.
Box square?
Yeah. X squared minus 6x plus something plus 4y squared minus 16y plus something equals 11, right? Now this is different because I'm not setting it equal to 0, so I can stick stuff on the other side and leave it there.
How come it's not negative 11?
Could you have to
I have to add 11 to both sides to get it there, right? Okay? So, let's go ahead and start completing the square. I'll have x squared minus 6x
plus 3?
plus 9, right? Because half of the center, half of that middle term, so 6 divided by 2 is 3. 3 squared is 9. Okay? What do I got to do on the other one before I can do completing the square? Factor out the 4, right? So I have 4 out here, and then y squared minus 4y plus 4, because negative 4 divided by 2 is 2. 2 squared is 4, equals 11 plus 9 plus 16. Why is it plus 16? Yeah, because this is 9 because there's nothing out here, so I just bring the 9 over, right? What you add to one side, you've got to add to the other. This is 16 because I added 4, but not just 4, but 4 times 4. That's why 16 comes over. Okay? So let's continue to simplify.
Did you factor out the 4 first, then
Yes.
go through the complete
Yes. Yeah. Got to factor out that 4 before you can do the completing the square. Okay, so negative 6 divided by 2 is 3. Okay? Alright, so let's go ahead and continue.
So since you factored out the 4, you just kind of re-multiply it back and then take it to 16?
Yes. Yes. Okay. Alright, so what do we have now? Yeah, we did that so that we could do x minus 3 squared plus 4 times y minus 2 squared equals 36. It's not plus 9 anymore because this right here is that completing the square, so we have the difference of squares now. That's why we did that. Because now it's starting to take shape more like our actual equations that we need. Okay, now here's the not tricky part, but something that you wouldn't normally think of. What is this supposed to be? 1, right? So how do I make this 1?
Subtract 36.
Okay, can't subtract by 35, so think of a different way. Divide by 36, right? So divide both sides by 36. That means you got to divide everything by 36. Okay? And now you can start to see where the fractions come. Because initially when you look at this, you might say, well, how am I going to get fractions? Because they're supposed to be fractions. Well, here they are. So x minus 3 squared over 36 plus, when I reduce, so y minus 2 squared over 9 equals 1.
Are they gonna always be perfect squares as well?
No. No.
We would hope.
Yeah, you can hope that, but no. Okay, and again, just to save time because we're running out of time, I would ask you at this point, this is where you would, the part of this problem would be to find that important information. What's my major axis? X-axis. Okay, horizontal is the right way to say it. Do we know that before?
No.
No, we know it now because it's bigger than 9. Okay, what's my center? 3, 2, right? Okay.
How's it 3, 2?
Because it's the opposite.
It's opposite. 3 comes out, 2 comes out. Okay, what's my A? 6. So what's my length of my major axis? 12. What's my B? 3. Length of the major axis? 6. And then we can find the foci, but we're not going to go through all that right now. What? This 4?
What's the homework?
Divided by.
Oh, so you took.
Divided by
Oh,
6
okay,
squared.
I was confused. Mr. Melvin, what's the homework?
Hang on.
You took all the 4s out, you took the 4 out, and then you divided.
Yes. Okay, I want to do another example before you go. Okay, I know we have 5 minutes, but we can work for 5 more minutes because we didn't even get as far as 5th period, and that's unusual. Okay, not right now. After class. Okay, now this one's a little different, and I want to go over. It's not any harder, but the thing about it is if you see this on paper and you've never seen it before, you might go, I don't know how to do this. Okay, again, it says the endpoints of the major axis are 2, 12 and 2, negative 4. The endpoints of the minor axis are 4, 4 and 0, 4. Which is actually my major axis here? Nope. Okay, vertical. Now look, here's why. If you look right here, you have, whoops,
Oh,
you have 2 and 2, right? So then you're dealing on this side, you're dealing with the y-axis. What's the distance between here and here? 16, right? So that's y, the distance is 16. And then on the bottom, you're looking at the same y, the same y. Okay? What is the distance between 4 and 0? 4. And that's on your x-axis. So your major axis is your y. So what form are we using? So y minus k squared over a squared plus x minus k squared h, over b squared equals 1. Okay. How do I find the center? Okay, distance divided by 2, but midpoint will actually be better. So I'm going to use the midpoint just to, skip the end. 2, 4 is your midpoint. Make a note, if you're taking notes.
Are we going to use the endpoints of the major or the minor?
Either one will work. Both of them will work. If it's the middle, it's got to work. And I've tested both of them, so they both work. So remember, make a note if you're taking notes that we did the midpoint formula, so you don't know, how did I get 2, 4? Use the midpoint formula, okay? So now, I can plug that in. I have y minus, what? 4 squared plus x minus 2 squared. What is a?
4.
Okay, it's 8, right? Because we said that we counted already, it was 16. That's the entire length. So divided by 2 is 8. So a is 8, so a squared is 64. What about b? B is 4. No, b is not 4 because the whole length was 4. So b is 2. 2 squared now is 4, right? So maybe that's what you were saying. Equals 1. So there's our answer.
That was a lot easier.
Okay? It's really not that difficult. I just didn't want you to freak out because you saw 2 points. Okay? So there's that. I will write your homework up here. It is page 586, 587, 9 through 29, odd.
9 through 29?
Yes.
I guess.
And the next thing you would do would be to graph it, and you'd have to graph your center, your foci, and then A and B.